Okay, so now that we've had a chance to kind of talk through the one-page notes about transformations, let's go ahead and answer these questions. So let's quick recap. We know that these are all going to be written in slope-intercept form. That's y equals mx plus b. When we talk about translations, though, we're talking about y equals ax plus k, where a is our slope. Negative is going to be flipped direction. And then the absolute value of that, if it's greater than 1, it's going to be steeper. And if it's between 0 and 1, it's going to be more gradual. Okay, so remember that from our notes. And that was all written here in kind of the quick one-stop shop notes. Okay, and then remember our K is our vertical movement, and so that's going to be positive is going to be going up, negative is going down from the origin. Okay, so let's kind of talk through these notes. So here we're starting with a parent function, f of x is equal to x. Here, without even having to graph it, I can automatically look and see what is different about these. So first off, it has a 2 for a slope. So I know that it's going to be steeper because it's going from 1 to 2. So it's a steeper slope. Okay, it has been vertically stretched by 2. Okay, that's the technical terminology. And then I notice here that there is a minus 3 out beside it. So the y-intercept is moved down 3 units. And the technical terminology is that it has been translated 3 units down. Okay, so that's the technical terminology, going from here to here. And now I can prove that using my calculator. So on my calculator, I'm going to go to y equals, and I'm going to do y equals x in the first one, and I'm going to do y equals 2x minus 3 on the second, and I'm going to graph them both. So there's my y equals x, and then I have y equals 2x minus 3. And you'll notice it's a steeper line, just like we thought. It's been vertically stretched, and then it also has been moved down 3 units. We've gone from the origin down 3 units for our y-intercept. Okay, so with or without the graph, we can still know the changes that have been made based on the equation alone when it's in this slope-intercept form. Okay, so now let's look from the parent function here. Sorry, there we go. From the parent function here to this y equals negative x plus 2. So notice it's a negative and negative 1 slope. So the steepness hasn't changed, but it has been, the slope has flipped direction. And so in technical language, we're going to call this a reflection over the x-axis. Okay, and then we notice it's a plus 2k, so that means that our y-intercept is going to be up 2 from where it was, and we call this translated 2 units up. Okay, and so that's going to be our changes. And again, we can check ourselves using our calculator. So I'm going to do y equals x for the first one, and y equals negative x plus 2 for the second one. And if I graph them, there's my first one, and here comes my second one. Same slope steepness, but it's flipped in the opposite direction, and we've moved it up 2 units from the origin. Okay, so nothing too crazy there. All right, now let's look at this one. Going from a 2x plus 2 to a 5x minus 3. So it's going from a 2 to a 5 slope. So it's not changing direction, but it is getting steeper. So we're going to say this is being vertically stretched yet again. Okay, it's a vertical stretch. And then here, we'll notice we have a plus 2 and a minus 3. So we've taken our y-intercept from a positive 2 all the way down to a negative 3. So it's actually moved more than 3 spots. It's moved 5 spots down. So the y-intercept has been changed down 5. And so we call this translated 5 units down. And we can double check ourselves yet again with our calculator. So we can do y equals 2x plus 2, and then we can do 5x minus 3, and we can look at these. So 2x plus 2 has a steepness of 2, a slope of 2, and it goes through the y-intercept of 2. Then the next one has the same direction, but it's much steeper, and it has been slidden down from the 2 to a negative 3. So it's gone down 1, 2, 3, 4, 5. That y-intercept has moved down 5 spots. And so that's the transformations that we're talking about from here to there. All right, and then the last one, we have x minus 4 and negative 1/2 x plus 2. So our a value has gone from positive to negative, so it has been reflected over the x-axis. And that means that we've just flipped it directions. It's no longer going positive, it's in a negative direction now. Okay, then I also noticed that I've gone from a 1 slope to a 1/2. The absolute value when we're talking about that, 1 to a 1/2. So it has gotten more gradual. And so we're going to call that a vertical compression or shrink. Okay, it's a vertical compression. It's getting more gradual slope. Okay, and then finally we get from a negative 4 to a positive 2. So we've moved up. So we have translated how many units? 4, 5, 6 units up. And again, I can check myself and make sure that that all makes sense, especially if I get tripped up on some of these. Sometimes it's nice to see. So I can do x minus 4. Oops. And then I can do negative 1 divided by 2, x plus 2, and I can graph each of those. So the first one is going to be x minus 4, and then the second one has a more gradual slope, and we've moved it up 6 spots, and it's been flipped or reflected over the x-axis, so it's now moving in a negative direction. So 3 different changes from one equation to the other. Okay, so these are transformations from one graph to the next. And so the big 3 key transformations that we want to remember are reflections. We want to remember a stretch versus a compression. And we also want to remember a translation. Okay, so reflection meaning A has become negative and we flip direction going from positive to a negative slope. Stretch and compression, a stretch means that our slope has gotten, the absolute value of our slope has gotten larger, so it's gotten steeper. Compression meaning the absolute value has gotten smaller, and so it's gotten more gradual. And then finally, translation is just a movement up and down. In this case, it's a vertical translation. Let's go ahead and clarify that. It's a vertical translation moving up and down. So when that k value is positive, it moves up. If it's negative, it moves down. Okay, so these are kind of just excuse me, the basics for translations for linear functions.